Hi, so this is a video editorial and screencast for the LeetCode weekly contest 499. I like this problem, especially Q3 and Q4, and I'll be going through the explanations of my implementations in the order of the appearance of the problems. And after this, I'll attach a live solve section where you can see how I approach the problems live in a contest setting scenario. Also, as a preface, like my implementations for Q3 and Q4 are really ugly. Like I don't know what happened. I'm sure I over engineered like Q3 and Q4 can be simplified as well. So I would recommend like looking at some other people's solutions after this as well. I did this for the bi-weekly as well, which is why I haven't uploaded the screencast yet. I might just upload the screencast and not the editorial because like my Q4 was a mess there. But alright, ignoring that, let's move to the explanations. So Q1 was fairly straightforward. Basically, we are given nums and we had to output a vector where output an array where the elements should be valid, and an element is valid if it is greater than all elements to its left, or it's greater than all elements to its right, and first and last are almost valid. So obviously, like at some index I, if it's first or last, we can push back into the vector, and if it's not first or last, we have to do this check where we check if it's maximum here or it's maximum here. Since the constraints are fairly small, for the max check we could use that. We can run another loop, or max element we could use max underscore element as well, but like you can simply create a prefix max and suffix max and then check in of one using that. So this was my implementation. This is the prefix max and suffix max. This is initializing them, and this is the loop with the condition where if it's first or last we push back, else if it satisfies either the greater than next or greater than previous, we push back. So this was Q1. In Q2 we are given a string with lowercase Latin, English, whatever characters, and we had to rearrange only the vowels such that they appear in non-increasing order, which means the vowel with the greatest frequency appears first and then the next greatest and so on. But if they have the same frequency, then we order them with their first appearance. So then obviously these are the vowels. So this is just a sorting problem now, and for sorting our keys would be the frequency and the first appearance, right? So we create a frequency and first, and we track both of them. Yeah, so we create a frequency. This is counting the frequency. I counted it for every character, but we only care about the vowels. And this is the first occurrence. I initialized it to a very large number, and now what I'm doing is, for if it's a vowel, I'm pushing it back into my IDX. IDX will contain the indices of the vowels, right? Because the problem is we have to only sort the vowels. The rest of the string should remain unchanged, right? So here, to do that, to achieve that, I am using an array of indices of the vowels, and here and now I'm also minimizing the first occurrence of every character because we want the leftmost occurrence, right? And now in my sorting, if the frequency of both the vowels are same, here since IDX will only contain the indices of the vowels, if the frequency of both the characters are same, then we sort based on the smaller first occurrence, else we sort based on the whichever has the largest frequency. And now why am I reversing this? Reversing is just to make the implementation easier, because since I'm reversing it, now my key which should come first would be at the last, right? And now simply when I'm iterating from forwards in the forward direction, I look at the last element. Since I've reversed it, it is technically the first one, and if it's a vowel, I'm doing this replacement, else I'm just pushing it back. So this was Q2. Q3 was fairly straightforward as well. Sorry, my bad. It wasn't straightforward. At least my implementation wasn't straightforward. There is probably another solution which I'll hint at or something, but yeah. Q3 was basically we are given an array and we can do an operation, and the operation is select this subarray L2R and increment all elements by plus equal to x. Yeah, x, and x is greater than 0. And we have to find the minimum number of sums of all x's such that we have that, what do we say, the array becomes non-decreasing, and non-decreasing is like something like this where it's not decreasing basically. Yeah. So my initial idea was, okay, maybe some sort of monotonic stack thing would work, where which still might work, where at some index I, if we look at all elements which are less than it, right? And these all have to be increased to this. So we have the count. Let's say we have the max element here as well. We at least we get those there. But then I couldn't like think properly about. Then I couldn't unfortunately think properly in this direction. So my implementation is kind of different for this problem. Basically now what I'm doing is also like do check some other people's solution for this as well. That might be way simpler and it might have a better idea. But my idea is assume we have a range L to R. If we want to do the operation on this range, what we would do is let's say this is initially the entire array, right? So 0 to n minus 1. What I did was let this be the maximum index, right? mx underscore idx, and if there are multiple, let it be its first occurrence. Now we have this array is partitioned into two now, the region behind mx and the region after mx. Now technically if we look at the region behind mx, since all of these values are less than equal to mx, right? mx is the value, mx underscore idx is the index. Since this is mx, all of the values here are less than equal to mx, so we don't need to do anything there. But to its right, we have to do something, right? Basically we have to increase them. So what I'll do here is, my idea was I would only, let's say, and here in this range we have some mx dash with which is at mx dash underscore idx. Same rules apply here, it's here. So and if the difference between the second largest and the largest is, let's say, some diff, here I can increase all elements by diff together, right? Because after I increase all of these elements by diff, mx dash will reach mx, but mx dash will reach mx, right? Which means these two elements should be equal, which is the bare minimum of what we want, because then at least these are not decreasing, right? And here we have already done diff operations. And now if we go to here, we'll see that basically then we can apply a sort of a same logic here, where now if we look at the next one, we simply have another, let's say, mx double dash, which is at mx double dash underscore idx, and we will try to increase this by the difference which is between these two, right? Because this difference is the difference which is this has already been increased by all, right? So we only need to care about this element, so we'll try to increase it by this difference. And for this direction again, we don't do this since it is less than this, but we would want to increase it by whatever mx is present here, right? Because this rule can apply there as well. So I implemented this sort of like pseudo divide and conquer approach, and for finding mx idx and mx I use this parse table. This is why I'm like wondering, this is probably not the best implementation for this solution, but here the L and R is the range and extra is the number of operations we have already done, which is for figuring this out basically. Since here we have already increased values by this amount, we don't need to increase that again, so I'm just telling that here basically. mx val and mx idx will give me the maximum value, and maximum value is index, and the previous value would be the amount which is behind it. So if no elements are behind it, it can be 0, but else it's the maximum value right here. So I'm using that as a query as well. So here, like if I'm considering this one, I'll do a maximum on this region, which will give me this element. Extra would tell me I've already done the diff operations. Like here I calculated diff, right? So extra would tell me that I've already done the diff operations, and the actual value would be the max value plus extra, because I've already done diff operations, right? So this is max value plus extra, and the amount which is required to be added is the value which was behind me plus the actual value, like the after a padding, right? And obviously clamp it, so because it can't be negative. So here we have added add, right? So to extra we add, and since add was an operation here as well, we add it to our answer, and we return the answer from the left and the right side. So this was my implementation. It's sort of weird, and probably I'm sure, like, since this approach, it can be converted into a O of n solution, I guess, as well, if we use monotonic stack. This is n log n, right? Because we are using a n log n pre-compute for the sparse table, and then this will visit every index at most once, since this is like the subproblems are not overlapping. So basically we'll visit the max, then we'll visit this max, and so on. We are visiting every max only, right? And these regions are non-overlapping, since this is max minus 1 to L and max plus 1 to R. So this was my Q3, and this is Q4. Again, this is over engineered as well for some reason. Like, I'm sure there's a simpler solution, but this was what came to my mind first during the contest. Basically, we are given an array nums, and if to put it simply, we have to find the subsequence where the elements are alternating. That is, the values are like this. Oh my god, the values are alternating of the elements. So we have 5, 7, so the next value should be less, right? So 4, and then the next value should be greater, so 9. The values are strictly alternating, and the difference of between the indices of these values is greater than or equal to k. So my first idea was, okay, we can do a sort of DP approach here, where let's say I'm at some index I, and I have some value AI instead of nums I. Let's let it be AI. So what I would do is, for all j which is greater than or equal to I plus k, this would ensure that this for all j greater than or equal to I plus k would ensure that the distance is at least k, right, between the next index. I made a DP. Let DP, this I'll talk about it later. I mean that I have chosen the ith value in my subsequence. So at the bare minimum, DP this xi, I'll say what x is afterwards, xiv. Since I have chosen the I element, the answer will be at least AI, right? Now, since the problem states that single elements are valid answer, here if you look, 5 is a valid answer here. So even if we don't find any valid element at this index, like this index doesn't exist or the alternative rule is not followed, at the bare minimum we have this to be true. Now for all j, what I was doing was I was iterating and checking if j is greater than, if aj is greater than ai, or if aj is less than ai, because that would mean different rules, right, for alternating. So this different rule gave me the idea for the second state, which is x. Now x is basically telling if x is 0, that means I'll try forming a decreasing subsequence from here, and if x is 1, then I'll try forming an increasing subsequence from here, right? So basically this gave me the n square DP idea, which is this. Wait, I submitted that, right? Yeah, this is my n square DP idea. First of all, obviously ignore the segmentaries, that's for the optimization, which I'll do afterwards. We go from, since I depends on a index greater than I, we go in the reverse direction. And x, obviously we can either try forming it increasing or decreasing one, right? So dpxi is nums I, which I stated, because dpxi states that the score starting from index I with the trend x, and trend is 0 means decreasing, 1 means increasing, such that the index I is taken. So this would mean that this is equal to nums I at the bare minimum. Now I'm running this loop, j from I plus k to n minus 1. Obviously this is to ensure the k distance. If x is 0, that means the next element should be less than this, right? So if x is 0 and nums j is less than nums I, that means dp x plus I is equal to, now I'm taking this nums I plus x zor 1 j. Why am I doing zor 1? X zor 1 means, let's say I was doing for x equal to 0. That means that nums I, I have this trend. So when this is for I, and now then for some j, the trend should be increasing, right? So this zor 1 makes that this x0 means 0 zor 1 means this would become 1. X zor 1 would become 1. So from there the DP would get the answer from the increasing trend, which is why it is zor 1. And similarly, if x is equal to 1, that means nums j should be greater than nums I, and then the trend should be decreasing. But then, so we can just keep this zor 1 thing. So yeah, and at the end we maximize, since the answer here means that we are taking numsci, right? AI, we are taking AI. Then basically we have to maximize the answer across all indices, since the answer is not guaranteed to be at num0 at a0 or whatever. So yeah, this was my idea. But here obviously this is n square and won't pass of this j loop. So to optimize this, my idea was basically, and the constraints here again. What happened? Yeah, the constraints are this: n less than equal to 25 and numsci less than equal to 25. So this numsci less than equal to 25 was key. Basically, what we are doing at some, let's say, x comma I, which uniquely identifies our state, right? If x is equal to 0, that means our trend should be decreasing. So the next value should be less than numsci or ai, whatever. And if x is equal to 1, that means the trend from I would be increasing. So the next value should be greater than numsci. And from here, from this set of values, we want the max, right? And obviously these set of values would have their trend as well. So along with this dp xi or whatever, I'm also maintaining this. What am I maintaining? I'm also maintaining a data structure which would allow me to get these whatever values, some values stored from keys which are less than equal to ai and keys which are greater than ai strictly. So for this I used a segment tree. There might be a simpler solution, but this is what I did during the contest. I used a segment tree where the trend, again we have the same thing, let segment tree be st. So the x thing is same, the trend, right? But here instead of I am storing stuff based on the value, so y. So the segment tree x y would store the answer uh, based on the x trend, where the first value in the subsequence is y. So yeah, this would mean that when I'm at some x comma I, if x is equal to 0, that means next element should be less, right? So I'll query my segment tree 1, because from this next it should increase, right? Because like this 0 then 1, all values, the query would be from the minimum value to ai minus 1, so strictly decreasing, and the query would be obviously of the max element. And similarly, if x is equal to 1, then it should be st0, and then the query would be from ai plus 1 to the whatever the max element is there. And now we also have to ensure that we are following that k distance rule, right? So for that k distance rule I simply did this. So my idea for the k distance rule was simply update the values in my sector after a delay. So basically, like at some I, our next index which we should start considering is j, which is I plus k, right? So obviously if this is inside our range, what we do is we get the value, and in the x segment tree we do this for both x0 and 1. We update the thing at that value, because as I said, this segment tree is the, instead of indexes we are dealing with values, so we can do that very quickly, right? And then we put whatever the dp value was present there, and these dp values were calculated at that time. This such that segment tree is being updated with a delay. So this k delay allows us to follow this rule, and the segment tree being on values allows us to query the less than and greater than part. Again, I'm sure there's a simpler solution. This is just the first thing which came to my mind during the contest, and after this I'll be attaching the live solve section. Alright, bye. क्यों है यार? अच्छा, प्रेस करने की ज़रूरत भी नहीं है। हाँ, ये सही है।